यार कहीं रखने वाला सही होता तो।
ठीक है।
यार सही नहीं है यार, ऐसे रोहित को दिखाता हूँ।
सर सर वो सर देखिए शो हो रहा है। हॉरिजॉन्टल करो इसको, हॉरिजॉन्टल। अब देखिए ट्राइपॉड कहाँ से, ट्राइपॉड है कुछ है, कुछ है।
लेकिन कैमरा लगा देगा चलो मैं इतने की लगा दो
अरे सर कैमरा लगाने में मतलब कब मतलब लैपटॉप में आवाज़ नहीं आ रही क्या?
म्यूट है ना म्यूट वहाँ से म्यूट
आवाज़ नहीं आ रही
म्यूट वहाँ से किया कुछ नहीं
कुछ नहीं वहाँ से
मतलब जब ये बोलेंगे तो लैपटॉप में आवाज़ आएगी बस ठीक है। ये पंखा बंद करवा दो। तुरंत सरसराहट खत्म हो गई।
नहीं बोलेंगे
आवाज़ इसकी फुल कर देंगे
फुल फुल
यहाँ पे ये
फुल है।
बोलेंगे
आपका मोबाइल भी साइलेंट है कर दीजिए। ठीक सो गए। जी बताइए। हाँ कौन से? हाँ नहीं आ रहा यहीं पे है दूसरी दुकान पे। म्यूट म्यूट है सर। लैपटॉप में आवाज़ नहीं आ रही। लैपटॉप में नहीं आ रही हमारा
क्या
लैपटॉप में आवाज़ नहीं आ रही।
है सब सही ना है
सर चल सर ये दूसरे सिस्टम पे करिए आवाज़ क्लियर नहीं आ रही लाइन से आप सुनिए। क्लियर है
ये आपकी मोबाइल चल रहा है ये फटाफट
लाइन से जा रहा है आवाज उसके अपने दूसरे लैपटॉप के सामने करने की जिसकी वॉइस क्वालिटी सही है। तो आप लोग यूज कर लीजिएगा लैपटॉप को।
उनसे कभी इतना घुमाएगा उनसे घुमाएगा
ये हटा दीजिए, चार्जर हटा दीजिए।
इसमें तो सही आ रहा है इसमें ऐसे क्यों आ रहा है लैंडस्केप है इसका ये स्क्रीन पे
ये वाला नहीं,
यूट्यूब पे चलाएगा, यूट्यूब पे क्यों चला
यूट्यूब
रहे
वाला
हो?
नहीं,
यूट्यूब वाला नहीं
ये चैनल
ये रुक
जूम
जाओ,
मीटिंग
चला
चलाओ।
जूम मीटिंग ओपन करा जूम मीटिंग
सर थोड़ी देर होल्ड कर लीजिए इसको, मैं पूरा वो दिख रहा हूँ ना क्या कर रहा है।
शिक्षा, स्वास्थ्य, बैंकिंग, उद्योग जैसे क्षेत्रों में भी AI तेजी से बदल रहा है और
थोड़ा सा इसको नीचे करा।
90 डिग्री, हाँ इतने
स्वास्थ्य के क्षेत्र में जैसा आप लोग
यूट्यूब खोल लो।
जबरदस्त इसमें इन्वॉल्वमेंट हुआ है। शिक्षा में ये स्टूडेंट की आवश्यकता के अनुसार की सुविधा प्रदान करता है। AI के अनेक लाभ हैं, लेकिन इसके साथ कुछ चुनौतियां भी इससे जुड़ी हुई है, इसको भी हमें देखना होगा। रोजगार का प्रभाव निश्चित रूप से इस पर पड़ेगा। डेटा की गोपनीयता और तकनीक के दुरुपयोग जैसी समस्याओं पर भी ध्यान देना आवश्यक है। इसलिए AI का उपयोग जिम्मेदारी और नैतिकता के साथ किया जाना चाहिए। भारत, जैसा कि हम जानते हैं कि एक कृषि प्रधान देश है, जहाँ की 80% से ज्यादा जनसंख्या कृषि पर निर्भर है। निश्चित रूप से इसमें कुछ फर्क पड़ेगा, लेकिन इसमें जैसे कि मौसम विज्ञान और जलवायु परिवर्तन, पानी की कमी इत्यादि जो क्षेत्र है, इसमें AI का उपयोग जो है बहुत बखूबी किया जा रहा है। ऐसे में आर्टिफिशियल इंटेलिजेंस कृषि क्षेत्र में क्रांतिकारी बदलाव ला चुका है और AI की सहायता से किसान मौसम की सटीक जानकारी प्राप्त कर सकते हैं। ये एक बहुत इंपॉर्टेंट इंट्रोडक्शन हुआ है एग्रीकल्चर के क्षेत्र में, क्योंकि मैं कृषि विज्ञान के क्षेत्र में रिसर्च करता हूँ, इसलिए मैं थोड़ा सा फोकस करना चाहूंगा। और AI की सहायता से किसान मौसम की सटीक जानकारी प्राप्त कर सकते हैं। इससे वे बुआई, सिंचाई और कटाई का समय तय कर सकते हैं। AI आधारित मोबाइल ऐप्स और सेंसर फसल में कीटों, रोग की पहचान आरंभिक अवस्था में ही कर सकते हैं, जिससे कि उनका समुचित समय पर उनका निदान किया जा सके। आप लोगों ने ड्रोन के बारे में सुना होगा। ड्रोन और हमारी स्मार्ट खेती की मशीनों से निगरानी की जाती है तथा उर्वरकों और कीटनाशक का संतुलित उपयोग सुनिश्चित करती है। ये एक बहुत क्रांतिकारी इंट्रोडक्शन हुआ है कृषि के क्षेत्र में। इससे लागत कम होती है और पर्यावरण की भी रक्षा होती है। हर तरह से हम इसको कंट्रोल कर सकते हैं। AI मिट्टी के स्वास्थ्य विश्लेषण करके किसानों को उचित फसल चयन, फसल पोषक तत्वों के उपयोग के बारे में भी सलाह देता है। बहुत सही जानकारी आती है। फसलों की कलर को देख करके फसल में नाइट्रोजन की कमी है तो हम उसको आइडेंटिफाई कर सकते हैं। इसके अलावा AI के उपयोग में कुछ चुनौतियां भी हैं, जैसे तकनीकी जानकारी की कमी, इंटरनेट की उपलब्धता। ये निश्चित रूप से एक बहुत बड़ी चुनौती है, क्योंकि कई बार खेती के क्षेत्र में जैसे हम किसी किसान को कहें तो थोड़ा सा मुश्किल भी हो जाता है, लेकिन निश्चित रूप से हमारा देश इसमें काफी आगे बढ़ रहा है। गांव-गांव में इंटरनेट की सुविधा हो गई है, तो आज AI का उपयोग जो है किसानों तक बहुत आसान हो चुका है। और उपकरणों की जो लागत होती है, इस पर भी सोचना पड़ेगा, क्योंकि ये एक महत्वपूर्ण विषय है। लेकिन सरकार, वैज्ञानिक संस्थान, निजी कंपनियां मिलकर इन चुनौतियों को कम करने का प्रयास कर रही हैं। निश्चित रूप से मैं कहना चाहूंगा कि AI कृषि के साथ साथ विज्ञान के हर क्षेत्र में एक अग्रिम, एक उज्जवल भविष्य निर्धारित करता है। यह किसानों की आय बढ़ाने, उत्पादन में सुधार करने और कृषि को अधिक टिकाऊ बनाने में महत्वपूर्ण भूमिका निभा सकता है, क्योंकि कृषि एक ऐसा क्षेत्र है जिससे पूरे देश की अर्थव्यवस्था का बहुत बड़ा हिस्सा चलता है। यदि हम इस तकनीक का सही उपयोग करें तो भारत की कृषि और अधिक समृद्ध एवं आधुनिक बन सकती है। मैं समझता हूँ अभी काफी प्रोग्राम आगे ले जाना है, तो मैं आप सभी को बहुत बहुत शुभकामनाएं देता हूँ मैं। और आप लोगों ने मुझे इनवाइट किया, इसके लिए मैं बहुत बहुत आभार व्यक्त करता हूँ। बहुत बहुत धन्यवाद सभी को जिन्होंने मुझे इनवाइट किया और आज बोलने का मौका दिया। बहुत बहुत धन्यवाद। और इस कार्यक्रम को सुचारू रूप से इनॉग्रेट करने के लिए मैं निवेदन करता हूँ।
Thank you, sir. Thank you, lovely words. Now I would like to welcome our Thank you, Sonkar sir, for your inspiring word. आपने बहुत अच्छा बताया सर। एक as a citizen, as a part of the society, मेरा एक प्रश्न है सर कि हम लोगों ने कृषि में, एग्रीकल्चर में काफी वो डिपेंडेंसी प्राप्त कर ली। अब ऐसा नहीं है कि भारत जो है कृषि उत्पादों के लिए किसी दूसरे देश पे निर्भर रहे। लेकिन सर कहीं ना कहीं हम लोगों को लगता है कि उत्पादों में जो क्वालिटी वाला इशू आता है कि जैसे हम लोग अपने हम लोगों ने भी देखा है जनरल ये बन चुका है परसेप्शन कि तो प्रोडक्ट जो सबसे खराब प्रोडक्ट है वो भारत में रह जाता है और सबसे अच्छा प्रोडक्ट है वो डेवलप्ड कंट्री में भेज दिया जाता है। तो सर इसके लिए क्या कुछ, जैसे हम लोग कुछ सामान खरीदने जा रहे हैं उसपे सब लोग सर्टिफिकेशन भी होता है, लेकिन वी आर पेइंग बट वी आर नॉट गेटिंग द ट्रू प्रोडक्ट। तो सर इसके लिए शासन स्तर पे जो आप बड़ी पोजीशन पे है, डिसीजन मेकिंग में है, पॉलिसी मेकिंग में है, तो सर इसके लिए we are not worry about myself but we are worry about the next generation।
yes
कि जो उनको फीडिंग है वो सही हो रही कि नहीं हो रही है, and we are paying good amount, handsome amount of money। तो सर इसके लिए क्या हो रहा है? कोई ऐसा पोर्टल, कुछ ऐसी पॉलिसी जिससे at least we are paying and we should get the true product।
yes agreed। असल में मैं बोलूं, शुरू करूं?
हाँ सर
अभी हाल में ही एक बहुत बढ़िया सवाल आपने किया है, क्योंकि सच में हम भी मार्केट जाते हैं तो एक ये बहुत निराशाजनक सवाल आता है कि जो ए ग्रेड फ्रूट है या ए ग्रेड जो भी पेरिसेबल प्रोडक्ट है वो बहुत कम मात्रा में मिल पाता है। इसके लिए भारत सरकार ने हाल में एक प्रोग्राम लॉन्च किया है जिसमें मैं भी एक पार्ट रहा, और हम लोगों ने किसानों के बीच ज्यादा करके कि किस स्थिति में हमें फर्टिलाइजर या उर्वरक, कौन से उर्वरक देना चाहिए। जस्ट, हालांकि आप लोग एग्रीकल्चर के नहीं है लेकिन मैं जस्ट बताना चाहूंगा, तो इस पर हम लोगों ने फोकस किया कि जैसे ही पौधे में या जो प्लांट में फूल आ जाता है तो हम उसको एक जो जरूरत रहती है फर्टिलाइजर की कि नत्रजन नहीं देना है, नाइट्रोजन नहीं देना है, फास्फोरस, पोटास और माइक्रोन्यूट्रिएंट, इन पोषक तत्वों की जरूरत ज्यादा होती है, उस समय नत्रजन की जरूरत नहीं होती है। तो ये इस बात को किसानों तक पहुंचाने के लिए हम लोगों ने पूरे देश में, ये राष्ट्रीय स्तर पर शुरू हुआ है कि जिससे हमारे प्रोड्यूस का सभी का, क्योंकि अभी जो चल रहा है कि बड़े बड़े जो फार्मर है, जो इंडस्ट्रियलिस्ट है या जो प्रोग्रेसिव किसान है वही इस्तेमाल करते हैं इन चीजों को, लेकिन उनकी संख्या बहुत कम है, हार्डली 3-4%, 5% है। मेजोरिटी तो जो मिडिल क्लास और लोअर फार्मर है, तो उन तक ये टेक्नोलॉजी पहुंचना चाहिए कि जैसे ही फ्लावर आ जाता है तो फर्टिलाइजर मैनेजमेंट, जिसमें मैंने बताया कि फास्फोरस, पोटास और माइक्रोन्यूट्रिएंट, इसको देने की जरूरत होती है जिससे कि प्लांट में न्यूट्रिएंट फ्रूट को डेवलप होने में हो और यूनिफॉर्म साइज हो। जैसे आपने कहा कि इसमें जो सेकंड ग्रेड या थर्ड ग्रेड होता है वो हमारे देश में मिलता है या हमें मिलता है खाने के लिए, तो जो डेवलप्ड कंट्री में, विकसित देशों में जो टेक्नोलॉजी यूज किया जा रहा है वो इस तरह से है कि प्लांट को जरूरत के अनुसार न्यूट्रिएंट दिया जा रहा है, जिसकी वजह से उनके यहाँ जो प्रोडक्शन होता है वो एक यूनिफॉर्म प्लांट को रिक्वायरमेंट के हिसाब से मिलता है। दूसरी बात, जैसे आपने देखा होगा मॉल वगैरह में कि स्पॉटलेस फ्रूट मिलते हैं, आजकल पैक्ड फ्रूट आ रहे हैं, रैप फ्रूट आ रहे हैं, तो उसमें कहीं स्पॉट नहीं आता है। तो उसमें क्या होता है कि एक बैगिंग टेक्नोलॉजी है जिसमें हर फल को बैग किया जाता है। जैसे ये फल है, इसमें एक पहले ही इसमें एक बैग लगा दिया जाएगा, तो जिससे क्या होगा कि इसमें इंसेक्ट का अटैक नहीं होगा। तो बाहर के देशों में ये चीजें काफी हो रही है, हम लोग थोड़ा इसमें पीछे हैं। इसमें किसानों को हम लोग ट्रेनिंग दे रहे हैं, जैसे मैं नागपुर में नागपुरी संतरे के ऊपर, मौसमी के ऊपर रिसर्च हम लोग कर रहे हैं। तो किसानों को ये बताने के लिए कि आपका ए ग्रेड फ्रूट बनाना है तो फर्टिलाइजर मैनेजमेंट, वाटर मैनेजमेंट टाइम से, प्लस बैगिंग टेक्नोलॉजी, जिससे कि फ्रूट जो है वो अच्छा हो, स्पॉटलेस हो और चमकदार हो, ये सारी चीजें इन्वॉल्व की जा सकती है।
आई होप सर कि ये सारी चीजें ग्राउंड पे आएंगी, है ना। एक अगर शुरुआत हो गई है तो उसका शुरुआत ही कहा जाता है कि 70% इज द इम्प्लीमेंटेशन। तो आने वाले समय में मुझे लगता है कि टेक्नोलॉजी का यूज करके वी विल बी एबल कि जो हम प्रोडक्ट ले रहे हैं ये आखिर जो हम पे कर रहे हैं तो उसका मुझे रिटर्न में मिल रहा है कि नहीं मिल रहा है। सर आपके इतने व्यस्ततम शेड्यूल से आपने समय निकाला और हम लोगों को सर ज्वाइन किया, इंस्पायर किया। इसके लिए सर रामस्वरूप यूनिवर्सिटी की तरफ से बहुत बहुत आभार। सर बताना चाहेंगे कि ये हमारा लाइव स्ट्रीमिंग भी हो रहा है। इसका जो है 300 कैपेसिटी है, तो 300 लोग जुड़ चुके हैं, बट 1400 have joined the FTP program, so they are watching the live stream as well. और फ्यूचर में सर we will be keep on taking your suggestions and directions to improve
मैं कभी भी तैयार हूँ।
and research excellence, and thank you very much.
बहुत बहुत धन्यवाद आपको इनवाइट करने के लिए आप लोगों को।
Now, I would invite our Honorable Vice Chancellor, sir, to motivate us regarding this FTP. Okay, somehow मुझे लगता है कोई मीटिंग वगैरह में बिजी हो गए। So, अच्छा सर, good morning, sir. Our Honorable Vice Chancellor sir has joined. Sir, I would like to inform that Dr. Sonkar sir has delivered the talk about this FTP. I would like to request you to motivate us to have some words regarding this FTP. Sir, 300 participants have joined here using the Zoom link, as well as live streaming is also going on. So total 1400 participants are engaged here in this FTP program. Over to Honorable Vice Chancellor.
Thank you, Vinit ji. Thank you so much. Distinguished Chief Guest, our esteemed resource persons, respected faculty members, researchers, dear students, all those who have joined online. Welcome to this FDP. It's a wonderful and a very, very apt topic, advancements in artificial intelligence and machine learning for real world applications. So on behalf of Ramswarup Memorial University family, I welcome all the participants on this FDP, and I hope that you will all benefit with the deliberations which we are going to have over a number of days, and with all the experts, those who have been lined up, and I will actually be sharing their experience and knowledge. Now, AI revolution. We all are talking about AI, and sometimes I find that people may be saying that AI is still something which is elusive, but the fact remains exactly the reverse. We are experiencing the impacts of AI, and we are very, very quickly moving ahead with AI, and almost every walk of our life is getting impacted through the AI. So if we actually go back in the history, whatever changes or revolutions we had, whether it is industrial revolutions earlier, or we got the electricity, or we got the engines to run us, all of them were changing our physical, whether movements, speed, or convenience. This is the first time artificial intelligence is going to impact our cognitive capabilities. So eventually, my ability to learn, reason, predict, infer, all these things are going to be impacted through the AI. So hence, eventually, as our cognitive abilities are impacted, sometimes they may be assisted, sometimes they may be distracted. So the issue is, are we prepared for it? And I think FDPs and our faculties need to impart this kind of awareness to my students and all those who are part of this FDP. Now, as the human capabilities get challenged, now it is up to us how best are we going to make use of it? Artificial intelligence is a very, very fascinating concept. Machine learning is in a supportive role, but there also the machines have been learning so fast that now they have started creating a logic of their own. They are, when they are given context, they are able to produce almost exact and the true results.
जो कमेंट दिख रहा है
Now,
ये भी देखना है।
various entrepreneurs and also experts in this field have flagged that we are creating some kind of a super monster. If leashed, then it will produce results for us. And if it is left unchecked, then definitely it may create a chaos. And we may lose the grip what we have over various walks of life, various parts of our activities, and academics is also going to be one of the most impacted areas. Now you just think about if an AI machine is employed in a higher education system. We are all talking about CLOs, PLOs and other things. We are always, as instructors, interested in what has been the gap in imparting educational training or industrial training. In case AI can assist mid-course or as we go by in a real time, what are the gaps and how they could be plugged, how they could be augmented through additional resources, it would be a wonderful thing for our higher education system. But issues, the negatives, we already have in front of us. Large number of research papers are getting copied, assignments are getting copied, or people are not paying a lot of attention to what the human being as a faculty is trying to impart, because the experiences and the correlations what human beings are still able to make, the machines are much far behind. So my view is we still have the relevance of our faculties, the experience, the knowledge which they have, they impart. However, they need to be assisted through large number of machines, softwares, and programs. Now, if I talk about little bit into cyber domain, I have worked in this area, so I can talk with some conviction and experience. The moment we are onto cyber offensive, as we are all talking, when there are economic interests that have to be met and the nations have to superimpose their will over the other nations, then cyber warfare is going to be one of the most important and most potent weapon to make sure that the will of one country is imposed on the other. Now, in that, the moment we plan for a cyber activity or cyber offensive or cyber actions on a wider domain, the first challenge which we face is you are deploying large number of codes, large number of assets to deliver information, and also you are flooded with so much of data that to analyze and take action in a timely, coordinated manner becomes an extreme challenge. You have to sit almost round the clock with complete alertness, and you have to, it is like searching a needle in a haystack, and that needle, the moment you find, you must correlate it with other similar needles, make a picture, act decisively, and must make sure that you are able to withdraw, keeping your tracks obliterated. Now this job is being done by the AI. Now I don't need to sit over the machine or over the systems. I mean, my AI is fully alert. All the programmings, all the identification methods and parameters have been fed into it. And the moment that particular needle is available in the haystack, AI quickly picks it up. AI has large resource on decision making. So it has, the moment some input, vital input has been received, it will be analyzed, corroborated, correlated, and then the action initiated. Now, human intervention may only be to an extent that what is the level of intervention that we are looking at. Rest the AI is there. Let's talk about health. We have to develop medicines, certain chemicals have to be actually studied over a large period of time. And you do whatever we were doing in 3 to 4 years, maybe that is possible in 3 to 4 minutes. Now you see how fast, how have we been able to compress the timing, and the chief guest has already brought it out. Agriculture, I don't need to be near my field. I only need to have my AI systems. The moment there is a requirement of any particular chemical or water or anything else, it is straight away given out to those who take decisions, or maybe given out to the systems, those who will be actually supplying that nutrient or water to the plant immediately. So this kind of artificial intelligence has given us the capability. Sitting here, I could be manning my farm 300, 500, 800 kilometers away, absolutely in a perfect manner. Manufacturing, Industry 4.0. Now we are getting into AI in every walk of life. So eventually, as we are talking, we're going to have large losses in the employment. My view is that we are only going to change the nature of employment. There would be definitely different qualifications and different skill sets would be required, but the jobs are not going to go away anywhere. So we need to change fast, we need to skill up, and this FDP is actually a right step in that direction. Now talking about a little bit on the generative AI, as we are moving into AI, currently we are firmly into generative AI, the large language models, in everything, whether it is a journalism or scientific research or manufacturing, as we talked about, or higher education, everywhere it is there. What is more important and which is getting more and more complicated is the context. Now, since AI has become intelligent now, and it has adequate database, and it's continuously learning. So there is a case of providing correct context before we get the results out of it. And hence that context is what the human beings are going to provide, and the outputs are going to be severely degraded in case the contexts are mismatched or confused. Lastly, but not the least, is the responsibility of the AI. End of the day, as we call, it is the man behind the technology which will make a difference. So eventually, artificial intelligence will provide us that leverage for some time. Maybe as we go forward, that will also not be provided, because I can foresee that the day is not far when the AI will get out of the hand, and those very few, those who are actually directly benefiting financially and commercially, would provide AI that kind of feature when it goes out of the hands and when it is actually not stoppable. So we all think that I will switch off the robot, I will take out the battery, I will disrupt the power system, I will do this or I will do that. But we rest assured, when the machines become intelligent, they will store powers. They will also make sure that there are certain areas where the sufficient power is stored for it to rescue itself and be active for a limited period of time. So those are the issues which actually I wanted to prime my experts, my faculties as they go forward with the FDP. Please take a lot of interest. It's an extremely important and relevant topic, and I am very sure all the participants will be able to draw a lot of value out of it. My best wishes to the organizing committee, to the department, and to the institute. Please go ahead and do well. I would be on a listening watch on most of your deliberations because I am personally interested in this FDP. My best wishes to all of you. Thank you so much.
Thank you very much, sir, to enlighten us, to motivate us, to inspire us. We have noted down the suggestions, the points mentioned by you. Thanks a lot. Now, I would like to hand over the rest of
one minute, Dr. Vineet, 1 minute. Let me thanks to the Vice Chancellor from his busy schedule. He has taken up this time, and whatever he has spoken is very relevant. And wisdom he has shown, given the light to the AI topic is great. Thank you very much, sir, for your involvement with us and giving permissions for everything we are doing with your blessing. Thank you very much, sir.
Now I would like to hand over the rest of the part of this FDP to the FDP coordinator, Dr. Sota. Dr. Hello. Now I am audible. Now I would like to call Engineer Subhash sir. Subhash sir, available? Yes. Subhash sir, please unmute itself.
Okay. Am I audible now?
Yes, yes, sir. Please.
Okay. Respected Vice Chancellor Mr. Pankaj Agarwal, Pro Chancellor Ma'am Pooja Agarwal ji, Vice Chancellor Vijay Tiwari ji, Director IT Shri Apurva Anand ji, Head DC SIS Dr. Gupta, Chief Guest Dr. Sonkar, Principal Scientist ICAR. Very good morning to all of you and whosoever is present online and part of this FDP. Good morning to all of you. First of all, I would like to thank the management of SRMU for giving me this particular opportunity to be in front of you and to say a few words related to this particular topic. Yeah, please.
Sir, आपका वीडियो देखना सर, please on YouTube sir, please. Camera on, please sir.
My camera is on, but I don't know. I'm also not able to see this.
Okay. No. Please sir.
Yeah. So since I'm not from this area, like I'm not an academic person, I'm a hardcore industry person. I have almost 35 years of software cycle experience starting from batch processing. Most of you may not be aware about the batch processing. So say from batch processing to multi-client to ERP to web development, all type of development and phases I have seen in this industry. However, related to this particular AI, since I am working with ONGC, Oil and Natural Gas Corporation, which is a basically oil in PSU, we are into upstream. When I'm saying upstream, basically we are exploring, drilling and producing well. So I have seen all type of software cycle development into industry. Then coming to ONGC is always a pioneer in technology adoption. In late 80s, we had IBM 1083. That was one of the most powerful machine in India in terms of computing. In fact, prior to Param supercomputer, that was the most powerful machine in India. After that, we had the biggest ERP implementation in ONGC. We have implemented 18 modules of SAP in ONGC. That was the biggest in Asia. After nowadays, we are planning to procure 40,000 cores of machine. 40,000 core, it means a lot. 40,000 cores of machine for our processing, because processing requires a lot of cores. So just I wanted to tell you that we are always pioneer in case of technology adoption, although we are from a PSU. Now coming to this particular topic, advancement in the field of AI ML for real world app. Yes, Vice Chancellor has already told a lot. Whatever a keynote, as a keynote speaker, I'm supposed to tell you. Tiwari ji, Vice Chancellor, has already told you about that. Nothing is left much about those topics for me. But still, I have to touch some of the things. Yes, when we are coming to say advancement in case of IML, lot of advancements has taken place since last, I can say, 4-5 years, and it is because of three things mainly. First is availability of a lot of data, but question remains here is quality of data. Just take, let me tell you, I think other speakers before me also, they have told about the quality data. And as a software professional, all of you also know that in cyber, in say computer field, data is of very important, as we say that garbage in, garbage out. So quality of data is very important, and lot of data has been accumulated. That's why this advancement has taken place. But quality, sometime else I got the news that now for preparing the model, data modeling, industry is now depending on the data prior to 2024, because during after that, whatever data has been is available on the like net, it's all generated by the bot. So quality wise, you cannot rely on that. So for any data modeling, supervising any model for any particular machine of a particular approach of AI, that data quality is going to matter. The second thing is computing, fast computing. I think in curriculum also, you all know about the NVIDIA. NVIDIA is producing a lot of good chips, although those are very expensive. If you will put it into, say, production, you have to pay a lot of money. That again, that need attention. You have to reduce the cost, and most of these machines, chips, which are going to be used for AI, those are very much, you can say, energy consuming, and they are basically power guzzler. So that is again a challenge. I'm briefly touching all the topics also, because on the coming days in your schedule, you are going to have a session on the, I think, let me have what is the schedule of challenges also, and fast computing related to quantum computing something, although that is related to a particular topic. Hello, am I audible? Sanjay? Hello? 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 Hello?
Hello.
Yeah, am I audible?
Yes, sir. Yes. Thank you, sir. Thank you so much for wonderful words.
So I just want to say that there are good topics you people have selected.
Thank you, sir.
All the very best, because there are some 2-3 topics for me, which are quite interested to me. One is related to like Sanjay, I don't have to see this schedule. Yeah, one is related to blockchain. Artificial needs blockchain, emerging technology for secure real worlds. These two are basically two different technology that is going to be very interesting topic if I could attend it personally. How it is, because the blockchain is related to basically safety of data. You are going to store data on different nodes or say blocks, and AI is going to pose a severe threat in case of security also. So it's going to be a very interesting topic. Then challenges, yes, VC and other speaker also have already told in terms of the employment, in terms of say cybersecurity and other issues also. So overall, this session is going to be very fruitful, very informative, very all the very best to all the FDP and all the participants. Thank you.
Thank you so much for giving a wonderful talk and motivated words. मैं चाहूँगा सर कि भविष्य में जब भी ऐसा कोई एक्टिविटी हो, प्लीज आप हमें प्लेस करने के जरूर जुड़े सर आप.
Sure. Thank you.
Thank you so much, sir. Now I am calling. I am going to conduct first session in this activity. I would like to call Dr. Prasanna sir. Please continue this session, sir. Prasanna sir available?
I can push off, Sanjay?
Sir. Yes, sir. Yes, sure, sir.
Thank you.
Thank you, sir. Prasanna sir available? Hello? Am I audible, Prasanna sir? Dr. Prasanna? Hello? Sir, it's a mute, sir. आप mute हो गए, would you please? It's fine. Yes. Hello? Am I audible? Yes, sir, audible. Yes, audible, please. Share the screen, sir.
Yes, sir. Sure, I'll do it now. So for all the participants on the potential therapy and the associated, I congratulate for having this entire for this wonderful activity. So without wasting time, maybe appreciate the organizers from the Salamu for this wonderful opportunity given particularly to Sanjay sir for being important for a long time. So maybe I'll just share my screen and then we'll start working on. Okay. So, have you guys visible, sir? So, I hope you can see me, right? See my screen.
No, sir. I think this screen. Okay, sir. Now it's visible, sir.
Okay, fine, sir. Yeah, so this session's topic is quite interesting kind of previously new to you. But the actual fact is that this is one among the wonderful latest technologies or latest happenings that's happening over the computing industry. So the topic here is quantum machine learning for drug discovery. So considering that my audience may be new to both these concepts, one is quantum machine learning and drug discovery, I'll have a small introduction to these two, and my session is organized as follows. I hope my screen moves to the next slide. Am I right, sir? Can you see the agenda? Can someone answer? Yeah, the chat at least, so that I can have a visibility of the chat. Yeah, yes, thank you. So the agenda here is like, first let me introduce what is quantum computing, what is quantum machine learning, what is drug discovery, and I have three wonderful work that I have done already related to this quantum drug discovery, the initial stages of drug discovery. So, and also I'll just give future directions where it will be helpful for many researchers to take on this. So, since it's a faculty development program, I just wanted to give the basics as well as the research directions for which you can take this work further. So now, before entering to the, or just moving to the next slide, I'd like to tell why drug discovery is very, 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 very important. We all know that in 2019, the entire world was affected by a pandemic COVID, right? So during that time, there was no medicine, nothing was there, no drugs were there to treat COVID. So at the time, this thought process came to me like, why we can't use some computers, like computing algorithms to make this drug discovery a faster one. So already people have started working on it, and many algorithms are already there for drug discovery, particularly using machine learning and deep learning. My thought process was, okay, classical computing, machine learning, deep learning, they're all good. But what advantages we may have when we use quantum machine learning? So the outcome for that is the three algorithms you can see in point number 3, 4, and 5. A quantum simulation graph, quantum QFM, QKDTL, the target interaction. So these are the three major things I just wanted to discuss with you, so that it will give some insights about how this quantum machine learning helps in drug discovery. So now, what is quantum computing? So actually, it uses a concept called as quantum mechanics, and there are three other important things. One is superposition, entanglement, and interference. So what is the difference between a classical computer and a quantum computer is that a quantum computer actually exists in a position called as superposition, which means that there are three things here. Whereas in a classical computer, whatever we are using, the one which I'm talking now, it's a classical one which has got only 2 bits, 0 and 1. But in a qubit, the quantum bit, the third one is present, which makes things very much easier. To explain what is the third position, I can say that there's a coin, right? When we have a coin, there are only 2 sides, head or tails, right? But when we flip that up, while the coin is rotating, no one can say that whether it is the head or the tail position. So this position, we call it as superposition, the third one. So since when 2 can make wonders, the third one adding into that, it actually makes many more wonderful outcomes. So here, whatever I said, like the basic concepts of quantum computer are introduced here. One is the superposition. You can see the same head and tail example. Maybe I'll just use the marker. I'll use the highlighter. Yeah. So what is this superposition all about? You can see like, yeah. So here we have a classic bit like the head and the tail over here. Whereas these are definite. But when we just toss like this, you can see on the right hand side where my point is pointing, we have a superposition of both the zeros and ones. So this is the power of so.
उधर
हेलो प्रसन्ना सर,
ये नहीं आ रही।
हेलो, आई ऑडिबल?
जब हो गया
क्या अनम्यूट करना है हमको? सब यहाँ चले गए थे।
Yeah, I think now I'm unmuted, right? Okay. I think it got disconnected again. Okay, I'll just share the contents again. The entire screen I'll share for simplicity. Screen. Hello.
Yes,
Hello.
sir. Yes, sir. Yes, sir. Audible, sir.
Okay, I think I got disconnected in the middle.
No, no, sorry,
Okay.
sir. Yes, yes, yes. You are disconnected in the middle.
Yes,
Now your
yeah.
visual and now your screen is visual and actual is clear.
Thank you, thank you. So we have the next thing. So whatever the introduction part was there, it was about quantum computing, the basics. But now the problem is about quantum machine learning for drug discovery, like how machine learning can be used, particularly by using this quantum computers. So what we do is this quantum machine learning actually encodes the data into quantum states, like 3 states are there, and so we use various encoding techniques for biomedical knowledge. See, the application is drug discovery, that's all, but the basics are related to machine learning, particularly quantum machine learning. So it's basically a hybrid model. It helps to lower the energy and the computational cost. This is very, very important. So what we do is we are going to construct a circuit called as quantum circuits over here. You can see that in the slide. So we have a classic computers. You can see 2 bits are there, like one is white and another one is in orange color. And then what we do is we encode that by using this quantum embeddings. Like you can see quantum embedding over here. We encode that and then we go for this quantum higher spaces. So this is what actually happens over here. Okay. So okay, we are not able to move to the next slide. Yeah, now I am able to move. So here we have this comparison between this classical and quantum computing over here. You can see that the same 2 bits are over here, whereas at the bottom this diagram gives you a clear understanding about qubit actually works. So it is like 1, 0, but in the middle you can see some arrow marks in these 3 diagrams, right? So one is pointing towards 0, one towards 1, and one exactly pointing towards 0. So this is what we call the superposition. So when we move to the next one, how this quantum computing actually works. So the classical computer, we have a problem to solve. We write some algorithms, and those algorithms are coded in programming languages like C, C++, Java, etc. We use a compiler, we execute that. So we'll get some binary outputs over that. That again will be translated to high-level language. Whereas here, the quantum computing, machine learning, particularly how it works here is, okay, we have the same problem. We have the same algorithms, whatever we do there, but instead of writing a code here, what we do is we design parametric circuits. So how to design these parametric circuits? You can use Python programming languages for that, and there are a number of tools like Qiskit, 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 which will help us to design these particular circuits. And then the important thing is the compiler. So generally in classic computers, we have a compiler embedded in our hardware, but here it's somewhat not that simple as we think. We should have the hardware for that. the hardware is quite costly. It is not commonly available nowadays. It's very, very, very costly. Like in India, we have one quantum computer installed at CDAC Bangalore, 100 crores they have invested recently. And then we go for various optimization techniques, and based on those optimization techniques, you can see at the bottom execute QC, where this QC basically represents the quantum circuits. So we'll be executing the quantum circuits over here. So this is actually what happens in the quantum computing field. So this is a comparison. So no direct compilers are present here. We have a compiler, but the compiler is in the form of a hardware. Of course, it is a great challenge to every one of us. So this is the history of computing. I don't want to take much time. I have included everything in the presentation so that I will share this presentation with your organizer, so they can make use of it, and whenever they need that, maybe they can share it with your participants also. So what is the reason the inverter someone has mentioned? If the slide is inverted, is it so? And it does confirm I have got the chat window. Fine. So the next one is like the history of computers. This is the timeline of quantum computing. Again, as I told you, I just don't want to take much into it. But you can see that in 2010, the first commercial quantum processor actually was rolled out, right? Recently, even Google has said that quantum hardware has been given. So you can see the actual quantum hardware here. Picture I just inserted for those who have not seen it. So this will be like and production to them. Now let's move on to the next slide. What is quantum hardware and how it actually works? So as I told you earlier, the quantum computers works on qubits, control systems, and various measurement devices are there. Again, on your left-hand side, you can see the quantum hardware. So we use the concepts for this superposition, entanglement, and measurement for computation, which is making these things possible. So this is the basic hardware. Like we have the qubits at the bottom, which we call it as a quantum plane. Above that, we have the cryogenic control, we have the room temperature control, and then we have the classical computer on the top. So quantum computers doesn't work in a separate thing. We need some classical computations also. You can see here at the top. So we have the quantum plane at the bottom. We have the interface in the middle, and then the classic above the top of it. So this is one example for qubit. And what are the types of qubits? Like we have superconducting qubits. We have the trapped ion qubits, topological qubits, and photonic qubits. So it depends upon the company. You can see like IBM and Google use the superconducting, IonQ uses trapped ions, and Microsoft uses topological qubits. Xandu and Psi Computing uses photonic qubits. But basically the work is the same. So this is just an image of how this actual qubits actually work. Now, this is the layered architecture of the computer, the quantum computer over here. You can see the physical quantum processor at the bottom. We have the controls like microwave pulses above that, and we have like the readouts, which is nothing but the amplifiers for the quantum. And of course, we have the quantum error correction. So these three forms the physical layer of the quantum computer. Above that, we have the logical quantum processor, controls, and the quantum algorithms. So few quantum algorithms I have shared here, like Schwarz algorithm, Grover's algorithm, quantum simulations, etc. So this forms the logical layer. So what are the challenges in the quantum hardware and why it is not that much prevalent? The first one is the scalability and the error correction. Still, we have to move a long way, but now that few commercial quantum computers have come, we are in a little bit advantageous state over here. The other thing is that you might have seen in my previous slide that it uses cryogenic thing. So it needs a lot of cooling, and lot of cooling happens means we need a lot of power, right? Just like how our large language models work. So this is environmental factors play a key role in this quantum computing. And of course, the cost, as I told you, one computer costs 100 crores. So maybe it will take long time for that to get commercialized for personal use, right? It may take some time, just as computers took over a period of time to reach our our rooms. It will also, but one day it will happen. It may take some time. And then, there are different companies. I'll just have added a few slides on that also. The competition is huge among companies. They use different qubits itself. There's no standard here. And this is another challenge in this hardware. So, it requires dilution refrigerators, which is like colder than the outer space, minus some 100 degrees, etc. So they are extremely expensive, and it needs a lot of energy as of now. But soon things may change. And scalability, as we want to increase the hardware and all, it takes more time and all. Maybe fault tolerance and is another issue over here. Now, what are applications and the futuristic view of quantum computing? So, what we do is it plays a major role in cryptography. I think you might have studied that about that by classical computers over a period of 100 years can be solved by a quantum computer within some seconds, right? So, it plays a major role in quantum cryptography and autonomous systems, particularly like quantum key distribution, GPS for autonomous vehicles, robotics. The quantum computers play a key role. And another interesting application of quantum computing is the quantum warfare. It uses quantum communication, and it detects the underwater warfare, underground mappings, etc., etc. So quantum warfare is also soon people may see that. So what is the industry roadmap? As I told you before a few slides, industries doesn't have a common understanding of how this quantum computing works. Each and every company has their own style. So for example, IBM. So IBM actually was on the forefront of quantum computing. So they have an architecture called as bicycle architecture. So their main aim is to have scalable quantum computing, fault tolerance, addressable, etc., etc. And then we have, maybe I'll just keep all those things for time need. So we have their roadmap, IBM's roadmap, and they say that by 2023, they'll have quantum computers will run circuits comparing a billion gates and up to some 2,000 logical circuits and all it may build. So this is from IBM, right? So similarly, many other companies are there. I know that this may not be visible to all of you, but since I'm sharing this slide, you can have a look at it later after zooming this particular slide. The next point is that, Google. So Google Quantum AI has already introduced the small chip. I have included the chip here. This is the size of the quantum computer introduced by Google, and they have named it as Willow. Okay. So coming to Google, I just copied this. They said Google our quantum computing roadmap. They say the beyond classical thing, error correction, logic qubits, logical gates, engineering setup, and large-scale connected quantum computer they are going to build. And they said that they have had some achievement over here by releasing that window. And then Intel is the third company. First one is IBM, second one is Google, third one is Intel, which is also in this quantum race. So you can see the guy holding a quantum went over there, and you can see the hardware at the back, right? So 12 qubit chip has been developed by Intel. So they have a full stack program, full stack approach. You can see on the right hand side, quantum hardware, the spin qubit simulator, and then they have Intel quantum simulator, control electronics, control processor, and at the top we have the application requirements. Now, the first part of my talk was about an introduction to quantum computing, quantum algorithms, and how three major companies like Intel, IBM, and Google are in the forefront of the quantum race. Now, the application, where I'm going to use this quantum machine learning, right? It's the drug discovery. So, why is drug discovery so important, and why it is a need of the hour? I think I told you earlier, COVID, right? So, when I studied about drug discovery during the COVID time, I found that people took years and years to discover some drugs for some pandemic earlier that happened in the world. But just think about the situation where some 2 years, 3 years happened for the discovering a drug to COVID. The entire humanity might have been washed out by that time. But luckily, we had powerful classical computers, machine learning, and deep learning algorithms that were used to design the drug, right, for this COVID. So actually, it makes a critical global health challenge where people are expected to come out with very fast solutions for unexpected pandemics that may hit the world. Right? Already we have seen one such thing in our lifetime. So other than that, it is also used for identifying new medications for improving human health, particularly for diseases that currently lack effective treatment. For example, diabetics, right? India is known as the diabetic capital, and recently I read one newspaper that instead of daily having that insulin injection, they can have it once per week. So from 365 doses, they have reduced it to 55, something like that. So it actually directly impacts the life expectancy, quality of life, and of course economics. So drug discovery is a very important application. See, we concentrate a lot on finances like credit cards, fraud detection, financial applications, traffic monitoring, etc. But still, a wonderful domain for computing professionals is this drug discovery. So, what is this computational drug discovery? So, how it actually works? So, you can see some 5 stages over here. The first one is the target discovery. So, what is this target discovery? Target is nothing but a particular disease, right? A worm that creates a disease. It may be a bacteria, it may be a virus, etc. So we have to identify that target, and then we have to hit that, right, by using a certain amount of thing. For example, for that COVID protein, I think it was targeted, and they used another protein for coming out of that problem. So hit identification, and then we have to optimize that. We go for preclinical trials by using other mammals like rats and all, and then we go for clinical trials using human beings, and at the end, we come out with a drug. The major challenge here is that after the clinical trial, also few medicines fail, which means that after spending crores and crores of money and years of research, the drug is nothing but the medicine, right? So the drug may fail. So what we have to do is we should use this computational drug discovery process for effectively doing that. So what is the need for this? The first one is the increasing global diseases. Second one is unmet needs in drug discovery. Still huge potential of research is here, and then sustainability, particularly with the SDG goal number 3, well-being, health and well-being, right? And then, of course, the emergence of quantum computing, particularly Willow, makes this particular research domain very interesting one. So, what are the challenges in classical machine learning when compared with that of quantum computing for the drug discovery? First one is this classical machine learning. It uses or it needs huge computational cost, limited prediction accuracy. Since whatever data sets or whatever data we use for this drug discovery, the dimensions are huge, so huge that we may not be in a position to use the normal machine learning algorithms, since many algorithms may fail in tackling such things. And then the third one is the data complexity, which I was mentioning, right? The dimensionality is so huge that we may miss out something. And then, there is no sustainable thing over here, which frequently changes. That is not a major thing. So these are the challenges in classical machine learning. So what is the motivation behind this? There are 2 things. One is like the challenges in drug discovery, and the second one is the emergence of quantum computing. Now, as I told in the agenda, we are going to discuss about these three algorithms which we have designed in Amrita Vishwavidyapith in Chennai, along with my research scholar. The first one is a graph-based model. We call it dynamic test QSIM. And then we have QFM, it's a bioprediction algorithm, and we have the DTI, that is drug target interaction. So these are the three things which we will be discussing for another maybe 20 or 30 minutes. So what is the QSIM graph? So what it does is, it's a very novel graph-based algorithm. What it does is it combines the biomedical entity. See, let's not worry about proteins or sequences, DNA, blah, 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 blah. We consider that as a data set. Like how we have various attributes. For example, diegetic data set is a commonly used data set. People use it for machine learning, right? So what are the data that we will have? The BMI, height, weight, HbA1c score, pre-food score, after having food, what is the score? So some numbers will be there. Just like that it is also. We need not be medical professionals or pharmacists to understand this and everything. For us, it is data, right? So first one is the ATP extraction is done over here, and then we compute the similarity score, and we create a graph-based knowledge discovery by using quantum computing here. We actually used Qiskit for this, and this is the methodology that we use. So generally, as you know, any machine learning algorithm, the same process we follow. So we use tokenization and lemmatization for pre-processing the data. I think you know what is token, what is lemma and all. A token is the smallest entity which we cannot further split into smaller ones, right? And then lemmatization is like unwanted things can be cut off from the text. And then we go for similarity computation, entity extraction, and then group happens. This is we here used actually QK means, which is the quantum K-means algorithm. And then we what is constructed knowledge graph. Okay, so this is the output which is a biomedical relation two things. And here, I think I move to the next slide. Yeah. So here, it's a step-by-step process. I've given the entire step for your understanding so that it will be easier. So what we do is, this is the input pre-processing stage. Whatever text is there, convert that to lowercase. Remove the punctuations and special characters, whatever we do in natural language processing, we do it here. And then we create the tokens by the abstract CI towards the T of AI. Remove the start, removing the stop words, and then we perform lemmatization. So here the input was something like 10,000 and see, now what we do is we extracted that by using various NLP models, particularly for biomedical NLP. There are like SAI, SPAC. Okay, thank you. So again, it got disconnected. I'm sorry. I'll share my screen.
Now, sir, connected, sir.
Yes, sir. Yeah, sure.
Yes.
Yeah. I think the screen is visible now. There is some information in this Zoom. I don't know. Okay, okay. So here you can see that we can use a number of models over here, and we computed this by using this exact identity formula which is shown over here. So once this extraction has happened, we just use the TF-IDF. I think you are already familiar with this. Not maybe it's a very simple natural language processing concept where we calculate the term frequency and the what is it? Inverse. What is the term frequency and ideal response for the inverse document frequency, right? So you can see the formula over here to calculate this TF-IDF, and then we compute the similarity score. Okay, so you can see the formulas for everything there, and we go for the K-means clustering. So K-means clustering is a very famous algorithm, I think, in machine learning, which you might know. If not, also I think some sessions in the future we teach about K-means clustering. You in the step 6, you can see like the graph is constructed at step 7, and Polish graph construction happens over here. Maybe the metrics that you have used here is like cosine similarity, quantum similarity, etc. I don't want to skip all this. Let me skip few slides. And this is the important thing that I just wanted to show over here. Like, what is the difference between a classical computer and how this quantum computer actually makes our work more efficient? So on the left hand side you can see the classical part, and on the right hand side you have the quantum part. Okay, I think there's a small spelling mistake in the quantum part, but anyway, what is the classical part? See, this is called as cardiovascular diseases, like heart diseases basically. So on the left hand side, the classical part says that vascular diseases, hypertrophy, aortic arch, and polyagnetis. Okay, so these are the things that we can see. Whereas, if you just go to the right side, the part, you can see the same thing, the same vascular diseases, and at the end you can see polyagnetis. But in between, you can see that it has mapped with other keywords of. So it is not omitting anything that is related. See, if a disease happens, right? For example, I have fever. Okay. So what are the causes of fever? Fever could be caused due to anaphylaxis, like right? So the classical part actually what it does is it misses out certain things. Okay. Whereas the quantum part which has been designed, you can see here. The hypertrophy is at both the ends, no change. And then the aortic arch is on the both sides. But there are two important things. One is that arterial, whereas here this is those constants. You can see here this, I have marked it in red color. One is this atrial fibrillation, and another one is this congestive heart failure. These are the reasons. And you can see some scores also here, like 0.7, 0.73, 0.37, etc. So they are all interconnected with each other for creating this particular CV, that is cardiovascular diseases. So this quantum part explores nonlinear associations which are not captured by the classical vector space model. This is one advantage. You know, if we miss out certain things and do a wrong medication, right? So at the end of the day, our diseases will not get cured. So here, our classical machine learning models fails to identify certain points, key points over here. But you can see that it's very well captured by the quantum machine learning model, right? So this particular quantum model highlights indirect but medically relevant conditions. Even though they are not direct conditions, it also considers indirect things which will help in identifying the correct drug for a particular treatment. So concluding about this diffusion graph algorithm, so this extraction enables structured context-rich representations of unstructured literature. The thing is that we use the data set, which is totally unstructured. Okay, so due to the availability, non-availability of time, what I have done is I have not taken included everything, but maybe what I have done is at the end, I have given the publication details of how to download that, and you can read whatever we have done. And also, all these databases and the code, whatever we have done, is publicly available in GitHub. You can try on your own, like whether it actually works or not. So here, The thing is, you can see we have achieved approximately 21% of higher improvement compared to the classical cosine similarity, but still there's a long way to go, right? We can make it further effective and further efficient. The second topic that I told was QSF.
Hello. Sir, voice is not clear, sir. Not audible. Hello. Hello, Prasanna sir. Your voice is not clear, sir. Not audible. Hello, Dr. Prasanna sir.
Okay. I'm extremely sorry. Then there is some interruption. For the second time, got disconnected. But anyway, I'll share the screen again. I hope I'm audible now at least. Someone can just text in the chat window. Am I audible?
Yes, sir. Please audible, sir. Now,
Yeah. Thank you. Yeah, I think my slide is also visible, right, sir? Okay, thank you. So, just go to the screen mode. Yeah. So this particular algorithm is a prediction model that we used for predicting how it actually works. So now, maybe I can just have a walk through this. This is the methodology of the architecture diagram that we used. So what we did here is we used some biomedical data sets, and those data sets were given for the basic feature selection algorithms, entropy selections, etc., entropy calculations, etc. And we use this smart analysis. You know, as I was mentioning, this particular problem with biomedical thing is the data will be mostly unstructured and it is also biased. So we need to have an unbiased data, then we go for this smart analysis. So smart analysis is a very simple concept that is used by machine learning people in order to balance the data, right? So maybe I can say that smart cannot be used in all the times, but luckily it works for us. Okay, so which was like quite an interesting thing. Smart algorithm generally is an oversampling technique, and we use it for imbalanced data by generating some synthetic samples, right? We generate, since as I told you, like our Prime Minister told that writing in the left-hand node data is there. People will try to mimic the data, like they have one data, like a person writing in the left hand, they will create more such images, and those images will be used for training the data. So we use this smart analysis. Smart is nothing but synthetic minority, M for minority, and O for oversampling technique. T stands for technique. So synthetic minority oversampling technique is the one, and this generates synthetic data, and then we normalize the imbalanced data over here. In the previous algorithm, we used the K-means algorithm, whereas here we use a random forest. Okay, so quantum random forest is the one we use, and we compare that with the classical machine learning algorithms like basic random forest, gradient boost, and AdaBoost algorithms. So these are the process which we did for doing all those things. I'll just click this thing since we are like standard things, and you know the metrics like we use F1 score, accuracy, recall, ROC, that is receiver operating characteristics, etc. And we found that those results were really promising. So I'm just skipping all those results so that you can have a look at it later. So here the interesting thing is that I don't know, full screen mode, it's not properly working. Yeah, now it's yes. Okay. So you can see like the first advantage is that it introduces a novel hybrid framework where we use the classical as well as the quantum algorithm. And you know, at the end, we found that we achieved an accuracy of 92.7, which was really encouraged over here. And also, the main problem with quantum computing was its scalability thing. And whereas here, we were able to build some scalable, interpretable solutions which were performing very well, particularly when the data was imbalanced. Like for imbalanced data also, it worked very well. So this is one major advantage. And then this is the third session of, third part of this algorithmic series. One is QKDTI. So this is nothing but you can see that arrow mark hitting the target, right? So drug target interaction by using quantum thing. So we used an approximation algorithm called as Nystrom approximation over here. So this is the base for that. So we took the features, and here you can see for the first time the quantum circuit has been built. The parameterized quantum circuit has been built, and then this enhanced features we get out of it. Okay, I'm skipping a few things over here. And here, what are the contributions of those works, like how it helped in drug discovery? The first one is, it is like a quantum machine learning enhanced bioinformatics pipeline. Okay, so as I told you, the application domain is bioinformatics, whereas quantum machine learning algorithms can be used for other purposes also. And then it is like, as I told you, it's an open source QML research where all our work has been published in GitHub. Anyone can download that, re-experiment that, and check that. Third one is reduction in screening time and costs for the patients, right? So which is very, very important, since a longer screening time may not be good for the patient's history. So we actually care a lot about that by reducing the screen time and costs for the patients. And it provides, we work in line with the sustainable goals, like we support the sustainable healthcare innovation. And we have improved efficiency in early drug discovery, particularly for cardiovascular diseases here in this example. So there are a number of such diseases, a number of huge data sets available to the computer researchers to work on. So here, specifically, as you can see at the bottom, right, this aligns with the global goals such as the UN Sustainability Goal 3, good health and well-being. So what is the sustainability aspect that presents over here is it reduces the resource consumption. You may be asking, sir, at the start you told that quantum computers need huge cooling power and all. But even though it requires huge power for all those things, the time required and the computational cost actually is very less in quantum computing. That's why more companies are researching in quantum computing. Okay, so that's one important aspect. And it minimizes the need for extensive wet lab experiments. You know, the wet lab experiments are very, very costly, the chemicals, the synthesis and all. So, but we can here simulate, since it doesn't miss out any link that exists between the diseases. We are sure that we can go for the wet lab experiment at the end instead of doing it on a day-to-day basis, which obviously costs more time and also more money. More time in the sense, you know, few wet lab experiments, it needs 24 hours to get the results, 48 hours to get the results and all, whereas here we get that within a few minutes. And then it optimizes the computational resources, and it reduces the time and cost for drug discovery or drug development. And also it plays a major role in the environmental impact, since, you know, it reduces time, it provides us a faster way to design a drug or a medicine, something like that. So it really helps us to make things faster, right? Okay, and here this energy efficient quantum computing implementation is done. What are the potential challenges in particularly drug discovery and quantum thing is still the data quality and quantity issues are there. There people face a lot of such issues. And second one is like we have rigorous data cleaning process and validation. You know, most of the data available in PubMed, they are not structured, they are not clean. So it needs a lot of time for data pre-processing over here. Second challenge, third challenge is that additional databases like Drug Bank, Chembl are there. We have to explore those data sets and see the genetic things vary across globe. One medicine fit for an Indian may not be fit for the other genetic persons, right? With the different hereditary. So it's another challenge. And then the modern complexity and computational requirements, even though we claim that it's low, but still it is there. And the best solution for that is to go for a hybrid model where we use classical as well as the quantum approaches. And then maybe another thing is that we are all computer experts. And if you want to go for some validation, we can talk with some biologist, a pharmacist, or a doctor, and then we can do that. So these are certain challenges and certain mitigation strategies also I have given over here. So with this, maybe I'm just concluding my talk, and I have given my details over here. I'll just share this presentation to the organizer so that sir can do that. So maybe I'll just conclude now. If you have some questions, it would be better if you can type in the chat window. I'm happy to answer them.
Thank you so much, sir, for a wonderful talk for this MDP. I think any question from participant, you can write in the chat box. Any question from participant, please write in the chat box. Yeah, right hand. Anyone? Any question? Participant? Any question from your side? Hello? I think no question, sir. Thank you so much, sir, for a wonderful talk of this meeting.
Yes, sir. Thank you so much.
Thank you so much. And participants are requested to join 2:20 because 2:30 next session is going on. One thing, remember that attendance is monitoring my technical team, and feedback link is shared last day of this MDP, that is 18, 4 o'clock. Please don't write this type of message in the chat box. Thank you so much for joining us. Now we are meeting second session in 2:30.
मीटिंग में